Welcome back at the Technical Forum at the group exhibit Hydrogen Fuel Cells and Batteries. We're here at the Hanover Fair in the year of 2016. At this moment, I would like to say hello, welcome to all our online guests. We are live streaming from the fair. I'll be your moderator. My name is Mona and I'm the moderator of the Technical Forum. Our next topic will be industrial heat supplied by an integrated 1.4 megawatt fuel cell combined heat and power plant. And for that, please welcome with me on stage our next speaker, who is the Manager of Business Development of Fuel Cell Energy Solutions, Mr. Martin Ohmer. Big hands, please.
Thank you, Mona, for this introduction. Thank you for the presence. There's still some seats left to fill this. Okay. As already mentioned, we are talking about fuel cells in application, in the CHP application. And in the end, I will show you a 1.4 megawatt project in Mannheim. Well, I think centralized, we can say this, we can state this. Centralized is history. We have a lot of renewable energy and a lot of decentralized production. And this is needed for the flexibility of the energy system. First, short advertisement. Or the commercial, who is Fuel Cell Energy Solutions? Fuel Cell Energy Solutions is a joint venture between the Fraunhofer IKTS and Fuel Cell Energy. Fraunhofer IKTS took over the intellectual property of MTU On-Site Energy, and Fuel Cell Energy is a 650 employee company in US specialized on molten carbonate fuel cells. Well, Fuel Cell Energy is the market leader in the molten carbonate fuel cells. Right now we have 300 megawatt installed or in backlog. 110 direct fuel cell power plants produced already around about, where we are now nearly of 5 terawatt hours energy. And the highlight was in 2014, the 59 megawatt fuel cell park in South Korea. So you see, the fuel cell have reached a certain level of performance. We are not talking just about kilowatts. We are also talking about megawatts. Why CHP? Well, CHP is very efficient. I just show you some rough principle. The figures are just to show you the advantages. The big thing is, with a combined heat and power, you are using also the heat in a big extent, and that means reduction in emission compared to a centralized production where you produce the power in the power station and the heat somewhere else. And this gives you, the CHP gives you a certain advantage here. The fuel cell technologies, well, I mentioned molten carbonate. For the ones here who are not so familiar, we have certain types of fuel cells. We have, for the mobile applications, we have the PEMs, and you see this is range 5 to 100 kilowatts. Micro CHP, they have also the PEM and the SOFC, which is going to rough 10 kilowatts. Here we have the sub-megawatt class, which is basically the solid oxide and the PAFC, the phosphoric acid. And you see this stops here around about half a megawatt for one stack. And Fuel Cell Energy is working specialized on the molten carbonate fuel cell, which can going up to, with one system, up to 2.8 megawatts. Yeah, the fields of application, input-output fuel. We are fuel flexible. We can use with our molten carbonate the natural gas and also biogas. What's coming out? First, we have power with an efficiency of 47%. This is compared to other systems quite high level. Right now we are working with a 60% high efficiency fuel cell, but this is based on, this is focused on electricity production. So this is with less heat. And we have now reached 95, up to 95% of availability. What's coming out? The heat is, you can take out the heat with, in an exhaust stream with 400 degrees. And this is a big advantage if you need, for example, steam with 120, 150 degrees. So it's very easy to extract these steams with this 400 degrees. Compared to other CHP system, you do not need special heat exchangers or something like this. And you can make a two-stage extraction, so part of it goes into heat, part of it hot water. Also, cooling, no issue. You can work with adsorption chillers, and due to the high temperature, this is very efficient. And you see it also later. The H2, you can also produce hydrogen within the fuel cell, and this is in a flexible way. Emissions. I mentioned the emissions topic before. Due to the fact that we have no combustion in the physical sense, we miss things like SOx, NOx, CO. This is a comparison of our German Emission Control Act, the Technische Anleitung Luft. These are the limits, and this is what's coming out of the DFC. So, nearly nothing. You can say we have an exhaust air, do not contain any toxic things, and that means also for the application process, it's quite easy to site this fuel cell in areas with strong regulations regarding the emission topic. Well, the content of pollutants in the exhaust air compared to other systems. We have the regular engine, the microturbine, the gas turbines, and the fuel cell. So, you see the fuel cell is the cleanest application for CHP. How is the fuel cell done? What is inside? First, we are starting with a cell, the fuel cell itself, and for example, of the 1.4 megawatt, we have 400 components, 400 cells stacked together to one stack, which gives us 350 kilowatts electrical net. Taking 4 of these stacks together to make the module, and here you see the module with 1.4 megawatts, and 2 1.4 modules together are giving a 2.8 megawatts. So this was one issue, or one part, where we could significantly reduce the costs of the fuel cells today. Well, the power plant components. What basic components we have in a fuel cell power plant? We have first the module, which I mentioned before, which is the green one. What else do we need? We need the mechanical balance of plant, which contains the cleaning of the gas, the desulfurization of the gas, the water, cleaning of the process water. These are the main things which are here, the gray, and the electricity out of the module comes is a DC, and we have to convert it to AC, and this is done in the blue one. Regarding the output, we are quite flexible. What you need, 10 kV, 12 kV, 15, 20, no issue. Depends simply on the transformer. Here we have a layout of a fuel cell this is in Connecticut. The module. Here the water treatment, control panel, the exhaust, fuel desulfurization, and the switchgear, inverters, and the electrical balance of plant. And this is 8 meters by by rough 13 meters. So it's relatively compact and silent. This is near a university, so we have no issues with also with noise, reduced noise level, because we don't have combustion inside. What's making the noise is coming basically from the inverter and some blowers. The flows. Example, 1.4 megawatt system. We take ambient air, rough 6,000 Newton meters, norm cubic meters per hour. We have natural gas, rough 307 norm cubic meters, and we need some water. Part of the water is used directly for the reformer, for the steam reforming. And the exhaust heat, we have 750 kilowatts with an airflow of 6,700 Newton meters, and the power, which gives 1.4 megawatt net, which is roughly in a year between 11 and 12 gigawatts, depending on the hours. Basically, a fuel cell is used for continuous power, for baseload power. You can reduce the power with a certain ramping. For example, over weekend, seasonally ramping is possible. Yeah, we have some installation examples out of the US. Here we have a simple CHP, heat and absorption chilling. We have a grid application, rough 15 megawatts for Dominion Energy, which is supporting the grid. And also another example is a CHP in a university, as I mentioned before, just heat and power. The big advantage is here the savings. And here is also a big example for the power. You have out of the fuel cell high quality power. Well, this year in 2016 we will install the first megawatt fuel cell in Europe. The site is at Friatec in Mannheim. Commissioning will be in summer. In summer, we expect mid of July, and this will be the first molten carbonate, the first megawatt fuel cell for CHP application in Europe in an industry, in an industrial environment. This I mentioned already before. Here we have the output is planned with 11 gigawatts. The plant will run 8,000 hours. And we have exception, the heat is extracted with 9070, so it's used for hot water. And also regarding the emissions or the environment, we will save 3,000 tons per year. Well, as a summary, the advantages of the fuel cells in the CHP environment: fuel flexible, we increase the energy security, we have a higher electrical efficiency compared with other devices, we have up to 90% overall efficiency depending on the thermal output, Unique low emissions. So that means if you have for your building application to get the permit, it's quite easy. We have a no noise level, and no vibration. Hospitals, for example, where this is important. And the effective service, because we do not have moving parts. And this is at the end, a German topic. The fuel cells still get the 5.4 cent per kilowatt hour, according to the Kraft-Wärme-Kopplungsgesetz, the CHP law. So this is valid until 2017. Well, the outlook. What we are looking for in the future for fuel cell energy, we have the distributed generation. This is what we are doing now. We have the distributed hydrogen. We will take more efforts on research on hydrogen extraction to use it for industrial or transportation. Carbon capture, this is the big topic, especially in the US, to take out with a fuel cell, with a molten carbonate, take out the CO2 out of bigger coal-fired and gas-fired plants. And in the future, we will also work on the SOFC, especially to bring the SOFC in a power level of 200 kilowatt, 400 kilowatt, and compared with hydrogen storage. Well, that's it, and don't hesitate to ask some questions. I'm ready.
Thank you very much also from my side. That was Mr. Martin Ohmer from FuelCell Energy Solutions. Do you have any questions at this time?
So, all satisfied?
Still digesting all the information, still thinking about, can I have combined heat and power at my place? Well, you can take all your questions to the booth of FuelCell Energy Solutions. It's right across, not too far from here.
This direction, it's J50 at the German CHP community stand. And we have also up here, 10 meters up here, we have also a small booth.
Exactly, so one here in the hydrogen fuel cell and one over there.
Feel free to come over at our booth.
Thank you very much. Once again, big hands please for Mr. Martin Ohmer. Upcoming talk in only 2 minutes time will be a representative of AGFA. We'll talk about the Zirfon pearl separator membranes for highly efficient water electrolysis only in 2 minutes time.